So good afternoon, class. In the fundamental of physics, so far we had covered the basically the two topics which were of core importance. The first and foremost we had covered about the measurement part, and we had defined their measurement as measurement means to compare an unknown quantity with a known fixed quantity. Secondly, in the second chapter we had covered about basically the application of mathematics in solving the complex numerical problems. That is, how we are applying the mathematics part in order to understand the various laws of nature, the various principles of the physics. And we had we had encountered basically the two parts, the scalar quantity as well as vector quantity. And the scalar quantities are those quantities which we are describing only with the help of the magnitude. There is no role of the direction. In the vector quantity, we had described about basically in that vector quantities we are describing a particular object with the help of two entities, basically with the direction as well as magnitude. And we had learned about the addition of vectors, the cross product of two vectors, a cross b, a dot b. A cross b is the product whenever we are using the a magnitude of a into magnitude of b into sine theta into n hat, where n hat is the unit vector which is perpendicular to the plane containing a and b. A dot b is the dot product in which we are defining as a vector magnitude of a into magnitude of b into cos theta. Okay, so basically we had covered the two topics and which were of core importance. As of now, today we will be covering the third important topics, which is defined as motion in a rectilinear plane, or rectilinear plane here defined as the motion along a straight line. What is the behavior of a particular along a straight line? What is the characteristic of its transit whenever a particle moves along a straight line? So we will be just defining some of the basic parts, and thereafter we will go slowly and mechanically, and we will be diving slowly into the depth of this topic. So first and foremost, we had divided this chapter into 5 important parts. The first part is the introduction part. In the introduction part, we will be covering some of the important topics which we had already learnt in our previous classes, in our fundamental classes, and we will be just reciting, we will be revising those topics which will render more transparency, and our concept will be more clear thereafter. And secondly, I had documented some of the important topics here. The first part will be the introduction part, which will comprise the two subparts, that is the laws of motion and the inertia. In the inertia, we had inertia of rest as well as inertia of motion. The second is the location. The location means with the help of the coordinate axis, how we are determining the location of a particular point in the space, how we are inducing time, how we are defining the frame of reference, what is the behavior of a particle whenever a particle is taken into consideration with respect to a certain frame of reference. And third is the type of motion. This topic is basically dealing with the motion along the straight line. In addition to this topic, the motion along the straight line, we do have different kinds of motion. And what is the behavior, what is the tendency of a particle whenever a particle changes from the motion along a straight line to the circular motion? Different kind of motions will be there. We will be just going peripheral part of this thing. Now we have types of motion. We will be covering some important topics: the difference between the distance and the displacement, the speed and the velocity, and finally we will be having the acceleration part in this class. So switching over to the introduction part, what is motion? In a simple sentence or a simple meaning, we can say whenever a particle changes its position with respect to the time, we can say that particular object is in motion because its position is changing with respect to the time. And in physics, whenever we are defining a characteristic of a particle, whenever we are taking the account of its motion, we have to deal with respect to the time only. So whenever a particle changes its position with respect to the time, we can say that particular object is in motion. Okay, so There, apart from motion, we do have one more statement, that is basically the rest. So rest is just opposite to that of a motion. Whenever a particle is stationary, or its position is not changing, with respect to the time, then we can say that particular object is in rest, because its position is not changing with respect to the time. As per physics, that particular object will be classified under the rest. So we do have some important topics here. The first part is the laws of motion. In the laws of motion, as we had already studied in our fundamental classes, the Newton's laws of motion, the very famous statements proposed by the Newton, and we will be just reciting those lines, elaborating and rendering some transparency to make our concept more clear. So Newton's first law of motion. Newton's first law of motion states that whenever a particle is in the state of rest, or it is in the state of motion, it will continue its state until and unless an external force is applied so as to change its state of rest or state of motion. So that is basically the Newton's first law of motion. Any particle, it will continue its state of rest or state of motion as long as any external force is applied so as to change its state of rest or state of motion. That is the Newton's first law of motion. Secondly, we have the second law of motion. In the second law of motion, we will be coming into the derivation part also. We had applied the momentum part. How we had applied the application of momentum so as to describe the Newton's second law of motion. The Newton's second law of motion states that the rate of change of linear momentum is directly proportional to the force applied. So force is directly proportional to mv minus mu by t. We will be taking m as a common, m under bracket v minus u by t. As the standard equation of motion is v is equal to u plus at. By changing the subject of formula, we will be coming into derivation part, that is F is equal to mass into acceleration. That is the mathematically how we are describing the Newton's second law of motion. And regarding the statement, the rate of change of linear momentum is directly proportional to the force applied. That is the Newton's second law of motion. And this rate of change of linear momentum will occur in the direction of the force applied. That is the important thing. In addition to that, we have to add also that this change will occur in the direction of the force applied. The third law of motion, we will be coming to the Newton's third law of motion. In the Newton's third law of motion, every action has its equal and opposite reaction, but action and reaction does not act on the same object but at the same time. This is the basic clause of the Newton's third law of motion. Every action has its equal and opposite reaction, but action and reaction does not act on the same object, but it will happen at the same time. So that is basically the Newton's laws of motion. Switching over to the inertia. Inertia, it is an important concept of Newton's laws of motion, and we will be applying the concept of inertia in order to solve the complex numerical problems also. As studied earlier, as defined, inertia, whenever it is comprised of the two parts, the inertia of motion as well as inertia of rest. Inertia of rest, it is defined as, suppose a particle is in the state of rest, it will continue its state of rest until and unless an external force is applied so as to change its state of rest. Secondly, inertia of motion, it is also having the symmetric approach. So inertia of motion, it is defined as, whenever a particle it is in the state of motion, it will continue its state of motion until and unless an external force is applied so as to change its state of rest or state of motion. So basically inertia, it is an important concept, and we will be seeing the vivid examples which will render more transparency, and it will make our concept more comprehensive and simplified also. So this is basically the introduction part. Secondly, we are coming to the location part. Location, it is an important concept, because with the help of location only we will be defining the frame of reference, and in the physics point of view, the frame of reference it is an important concept. So we will be switching over to the location part. In the location part, we will take the help of a coordinate axis. Suppose this is the coordinate axis as I studied earlier in the mathematics. That is basically the coordinate geometry. With the help of coordinate geometry, we are determining the location of a particular point in the space. Basically, in the 2 dimension, we are taking the help of length and breadth, that is x-axis and y-axis. In the 3 dimension, we will be taking the help of 3 coordinate axes, x-axis, y-axis and z-axis. And whenever we want to locate a particular object in the space, we will be taking the help of 6 coordinate axes, x-axis, y-axis and z-axis, minus x, minus y, minus z. So that is basically the concept, underlying concept here. So it is basically, we have divided the 4 parts. The first is plus x plus y, secondly it is minus x plus y, third it is minus x minus y, and the fourth it is x minus y. So this is basically the location of a particular point in the 2 dimension. Whenever we are taking the help of only 2D, 2 dimension, 2 coordinate axis will be in the figure. It is x-axis and the y-axis. And whenever we are inducing a clock here, suppose we had induced a clock. Okay, suppose we had induced a clock and this is the particle, and if this particle is moving in this direction, so we had induced 3 topics here. The first and foremost, it is the location of a particular point. Secondly, the clock had been induced, and the third part is what is the movement of a particular particle and how it is in transit. What is the characteristic of its transit? So in this case, we will be defining like that. Suppose a particle, it is lying in the first coordinate axis, that is both axes, both quadrants will be positive, plus x and plus y, that is plus 3/4. Suppose a particular object is there whose the distance from the x-axis is 3 and the distance from the y-axis is 4 meter. So we will be just calculating the intersection point, and its coordinate axis will be entitled as 3, 4. And suppose it is the particular object, its coordinate axis, its position is 3, 4 in the space, and this particular object, it is moving in the left side direction. It is moving in the left side direction, and we had induced the clock also. So we had prepared a particular frame of reference in which we will be determining the position of a particular point and how that position is changing with respect to the time, because we had induced a particular clock also. So that these 3 properties, these 3 objects, so frame of reference, it is comprised of 3 parts. The first is the location of a particular point in the space, secondly clock, and the third is the transit, the motion along a straight line, how it is changing its position with respect to the time. So this is basically the frame of reference. And the frame of reference, it is very important in the physics point of view. Whenever we want to establish a relationship, or we have to check the characteristic of a particular point or a particular object, how it is behaving whenever it is in motion. So in that case, we have to select a suitable frame of reference. With the help of frame of reference only, we will be defining the location of a particular point, the relative velocity, and further more concepts will be elaborated. So choosing a particular suitable frame of reference, it is very important. So this is basically the second point. We had covered introduction and location and the frame of reference with respect to the coordinate axis. Secondly, we will be covering the most important topic. It is a basic part of this motion part, that is distance and displacement. It is distance and displacement. So we will be switching over to the distance and displacement topic as studied earlier. So distance and displacement, we will be taking the help of the scalar quantity as well as vector quantity. Distance, it is characterized under the scalar quantity. We can define that particular object with the help of its magnitude only. But whenever it comes to the displacement, in that case we will be taking the help of its magnitude as well as direction. So it is characterized under vector quantity. Displacement is a vector quantity. So suppose a particular object is stationed at A. This particular object is stationed at A and it is moving towards the right direction. And it attains the position B after some time. Suppose this particle which is moving here, it had came here, and it had reached to the particular point B. So the distance between the AB, it is the distance traversed by a particular object with respect to a certain time. So that is the distance, and suppose that is this distance is x meter. This distance is x meter, and in returning position again this particle is moving from this B and it had reached to the A, and this also distance is x meter. So totally the total distance the particle had traversed, it is 2x. Whenever we are seeing the distance with respect to the point of distance only. So total distance is 2x meter, and it is a scalar quantity. Now switching over to the displacement part. Suppose similarly, symmetric to the motion, the first and foremost particular object, if it starts from position A and it had reached to the position B, no matter which path it had taken or it had chosen, in that case the total distance will be from A to B, it is x meter, and if it moves back-forth motion is there, that is from B to A, then in that case the direction will come into picture. It will be minus x. So plus x and minus x. So totally, whenever we are calculating the displacement in this, the displacement will be plus x this part, and this will be minus x. So displacement will be 0 and the distance will be 2x. So that is basically the core difference between the distance and displacement. Distance is a scalar quantity, displacement is a vector quantity. Distance can't be 0. It may be negative, it may be positive, but it can't be 0. But displacement, it may be 0. And we had seen the example also. Suppose a particular object, it is moving from position A and it had reached to the position B after traveling some time. In that case, we had taken the distance as x meter, the distance between the A and B. And in the reverse direction, if the same particle moves from B to A, in that case it will be minus x. So x minus x will be equal to 0. So displacement will be equal to 0 and distance will be x plus x, that will be 2x. So we had seen the third topic, distance and displacement, and we had differentiated also based on the scalar as well as vector quantity, the important topic is there. Now we will be covering the important topic, speed and velocity. And we will be correlating the speed and velocity with respect to the distance and displacement topic. So regarding the speed and velocity. Whenever we are talking about the speed, again stating speed is a scalar quantity. We can define the speed of a particular object moving along a straight line having the rectilinear motion with the help of its magnitude only, and that the direction is having the null role there. And whenever we are talking about the velocity, mathematically stating both will having the same formula, that is dx by dt, okay, but in the velocity we have to take the direction also as well as magnitude, because it is characterized under the vector quantity. So velocity is a vector quantity, a speed is a scalar quantity. Velocity is a vector quantity. Understood? So we have defined the speed and velocity. Speed is the rate of change of a particular object with respect to the time. That is the speed. Suppose a particle covers a distance x with respect to the time t. In that case, we can say its speed is equal to dx by dt. Its speed is dx by dt, and it is a scalar quantity. Mathematically stating, speed and velocity will be elaborated in a similar manner, dx by dt, but in this velocity we have to take direction also. In which direction the particular object is moving, we have to take it into consideration. That is the velocity. Velocity, it is a vector quantity. Speed can't be 0, because we had already seen in the case of distance and displacement, speed can't be 0, and the velocity, it is defined as displacement by time. and the speed is equal to distance by time. Distance by time. So we had already seen this that distance can't be zero. It can be positive, negative, but it can't be zero if the object is in motion. So in this case, so distance, the speed will not be equal to zero in any of the cases. But regarding the velocity, as we had already seen, that displacement had become zero whenever the particle had returned from its final position to the initial position. So in that case, displacement is zero. Whenever the displacement will be zero, in that case velocity will also be zero. So we had differentiated speed and velocity. Speed is a scalar quantity, velocity is a vector quantity. Speed can't be zero, but velocity can be zero because displacement can be zero. So based on this, we have differentiated the speed and the velocity also. Now we will be switching over to the acceleration part. Now we will be switching over to the acceleration part. Acceleration is equal to rate of change of velocity. So acceleration, it is defined as rate of change of velocity. A is equal to dv by dt. A is equal to dv by dt. Mathematically stating, A is equal to dv by dt. A into dt is equal to dv. We will be integrating this 0 to t. So a t is equal to v, and it will be, suppose it is equal to v is equal to at. Okay. So we had already seen, if we are integrating it 0 to u, so it will be v minus u is equal to at. V is equal to u plus at, or v minus u is equal to at. So we have already seen how we are differentiated. It will be u minus 0. U is equal to at, or v minus u is equal to at. So we have seen the acceleration part. Acceleration, it is defined as rate of change of velocity. Acceleration may be defined as a rate of change of velocity, as displacement can be 0, velocity can be 0, and acceleration can be also 0. Acceleration is also, it is a vector quantity because we had already defined the acceleration mathematically. It is the ratio of change in velocity with respect to the time. So that is the acceleration part which we had studied. So we had in this class we had covered basically the motion along a straight line. Motion along a straight line, it means it is defined as rectilinear motion. Whenever a particular motion is moving forward or backward but along a straight line, then in that case it will be defined as motion along a straight line or motion along a rectilinear path. In some cases, the particular object moves along a circular track. That is considered as a motion along a circular track. That is a circular motion. Thirdly, a rolling motion will be there. It is moving also along a linear path, along a straight line, and it is rotating also. So that is considered as a rolling motion. So we will be seeing the different concepts related to the types of motion. We had seen the introduction part, location, the speed and velocity, the differentiation between the speed and the velocity, distance and displacement, and finally the acceleration part. So in this topic we had covered this type of this you can say this type of concepts, and I request my viewer, please go through the concept which I had taught today. If any issue is there, if any doubt is there, you can just comment in the comment box, and I will see that what is the issue we are facing as of now, and I will try my best so to resolve that query within the stipulated time. Till then, thank you for the day.